3i Atlas has all kinds of surprises. We've only seen a handful of blurry shots that look like a tail is kind of starting to form. There's the unusual chemical signatures. It's producing way more nickel than iron, and scientists don't really know why. And when it comes to size, some estimates say it's about 3 miles wide. In comparison, Manhattan, it's only about 2 miles wide, and that is at its widest point.
Interstellar object 3i Atlas reached its closest approach to Mars on October 3, passing less than 0.2 astronomical units from the red planet. This moment marks a critical period for observation, as several probes surrounding Mars have the opportunity to capture images and data of this rare interstellar visitor. However, this opportunity coincides with an unusual event on Earth: a United States government shutdown. The shutdown has suspended many NASA operations, leaving websites and social media channels inactive and depriving the public of official updates at a time when attention to the skies is most crucial. The timing is coincidental, but has raised eyebrows within the scientific community, as access to data about this unique event is limited by administrative paralysis. 3i Atlas has drawn significant attention due to its anomalous properties. Traveling at about 60 kilometers per second and projected to reach up to 68 kilometers per second near its perihelion on October 29 and 30, it moves faster than most known comets or asteroids. Its trajectory is unusually well aligned with the ecliptic plane of the solar system, and this alignment has sparked speculation about its origin. Some have even suggested that the object may not be entirely natural. While most researchers remain cautious, its peculiar features, such as its high velocity, the absence of a typical cometary tail, and its unusual brightness profile, have deepened the intrigue. At the moment of its closest approach, Earth-based observations of 3i Atlas have become extremely difficult. The object's current position places it near the Sun from Earth's perspective, meaning the glare renders it nearly invisible to ground-based telescopes. This configuration, known as a superior conjunction, effectively hides 3i Atlas from Earth's instruments. Recent imagery from late September and early October, taken before the object disappeared into solar glare, represent the last Earth-based views until it re-emerges later in its orbit. For now, Mars and its orbiting spacecraft provide the best possible vantage point. Fortunately, other space agencies beyond NASA are active. The European Space Agency has scheduled extensive observations of 3i Atlas during this critical window. Meanwhile, several Mars-based platforms, including the Perseverance rover and multiple orbiters, may already have recorded useful imagery. A notable example has already surfaced from Perseverance itself. On October 2, an observer analyzing the rover's sky images noticed a distinct streak across a sequence of frames. Over 9 minutes of data, the images revealed a bright object moving rapidly across the Martian sky. When examined closely, it did not match the expected motion of stars caused by Mars's rotation. Its path and apparent velocity were consistent with predictions for 3i Atlas's trajectory. The appearance across multiple consecutive frames ruled out the possibility of a camera artifact, indicating the rover had likely captured the interstellar object as it passed by. Analysis of these images provides limited but valuable data. The observed elongation in the exposures matches the object's direction of travel, reinforcing that the streak represents genuine movement rather than imaging noise. The sequence also demonstrates that 3i Atlas is extremely fast-moving relative to Mars's background stars. The estimated minimum diameter of the object, based on brightness and distance models, currently centers around 5 kilometers, though some analysts suggest it may be larger. Many amateur astronomers have managed to image 3I Atlas with modest equipment, suggesting a relatively high intrinsic brightness and possibly a large reflective surface area. Although the Perseverance imagery is low resolution, it supports the overall assessment that 3I Atlas is a significant and unusually bright interstellar object.
Because NASA's public data servers are currently affected by the shutdown, updates have been inconsistent. Researchers and enthusiasts are manually checking FTP servers and alternative data channels to locate new imagery and telemetry. Given the current administrative freeze, many expect delays of several days or longer before official releases become available. The European Space Agency and other national space programs remain operational, and their upcoming data will likely be crucial for continued observation. 3I Atlas has already been the subject of multiple observations in the past weeks, including a series of significant images taken between September 25 and October 2. The earliest in this recent series, captured by astronomers Gerald Raymond and Michael Yeager from Namibia on September 25, depicts the object before it encountered a coronal mass ejection, CME, emitted by the Sun. In that image, 3I Atlas displays a bright green hue and an unusual antitail, and sunward-pointing extension of gas and dust rather than the long solar-opposing tail seen in typical comets. Its structure and coloration indicate the presence of ionized gases interacting with solar radiation in atypical ways. Just days later, 3I Atlas was struck by that CME, raising expectations that its structure might change. Yet subsequent images, including those taken on September 27 by Mr. Romang, show little difference in appearance. The object's shape and brightness remained steady, suggesting a surprising resilience. The lack of a visible change supports the view that 3I Atlas does not behave like a normal comet. Most comets subjected to such an energetic solar event would exhibit fragmentation or increased outgassing. Instead, 3I Atlas remained largely unchanged. By early October, Romang's latest imagery still showed the same rounded coma and diffuse structure, albeit with slightly more ionized glow, likely due to continued solar heating. The observations collectively indicate that 3I Atlas possesses a large, stable coma, an envelope of dust, gas, and plasma surrounding its central nucleus. Infrared imaging and other analyses estimate this coma to extend nearly 700,000 kilometers in diameter, roughly half that of the Sun. This immense size, combined with the lack of a typical tail, challenges simple classification. Its ionization and symmetry are unlike those of other comets currently active in the inner solar system, such as A6 Lemon or R2 Swan, both of which exhibit well-defined elongated tails. Instead, 3I Atlas appears as a luminous sphere of diffuse material, glowing evenly and displaying structural layers with varying densities. Polarization data suggest that its outer and inner regions scatter light differently, revealing complex compositional differences within its surrounding envelope. This behavior complicates efforts to categorize 3I Atlas. While mainstream institutions like the European Space Agency continue to describe it as a comet, some independent researchers classify it more broadly as an interstellar object. Unlike typical comets, which follow elliptical orbits bound to the Sun, 3I Atlas follows a hyperbolic trajectory, ensuring it will eventually exit the solar system forever. Its direction of approach is another curiosity. The object entered the solar system from a region of the sky roughly 9 degrees from the location of the 1977 WOW signal, the unexplained radio burst once speculated to be of extraterrestrial origin. The alignment may be purely coincidental, but it adds a historical resonance to the event and has fueled public fascination with the object.
At this point, attention turns to the various spacecraft capable of observing 3I Atlas from Mars' orbit. The European Space Agency's Mars Express Orbiter and ExoMars Trace Gas Orbiter were scheduled to capture images and spectra of the object during its closest approach. According to ESA, the distance between 3I Atlas and Mars on October 3 was approximately 30 million kilometers or 0.2 astronomical units. Later in the year, ESA's Jupiter Icy Moons Explorer JUICE mission will also observe 3I Atlas as it nears perihelion and continues outward toward the orbit of Jupiter. Because of JUICE's current orbital geometry, data transmission to Earth will be delayed until early 2026. This delay means that the most detailed observations of 3I Atlas may not be publicly available for several months. Still, these measurements are expected to provide unprecedented insight into the physical and chemical nature of the object. Beyond ESA's efforts, other international missions may contribute. China's Tianwen-1 orbiter, which has been operating around Mars since 2021, carries multiple scientific instruments capable of imaging celestial targets. If Chinese mission planners decide to repoint those instruments toward 3I Atlas, the resulting data could be among the highest resolution available. Similarly, the United Arab Emirates HOPE orbiter could also observe the event. Both missions have scientific teams that routinely release data, though not always immediately. The participation of these missions would expand global coverage and help compensate for NASA's temporary inactivity. The NASA shutdown, affecting about 1.5 million government employees, has generated widespread uncertainty about ongoing projects. Some missions are deemed essential and continue operating autonomously, but many communication and analysis functions are paused. This means that even if spacecraft collect images or data, they may not be processed or released until the shutdown ends. The situation highlights how fragile the coordination of space science can be. While probes continue to function, the flow of information to the public and the scientific community can be abruptly interrupted by domestic politics. The coincidence of this administrative disruption with the close approach of a rare interstellar object underscores a systemic vulnerability in how scientific discovery depends on governmental continuity. In the absence of official updates, amateur astronomers and independent analysts have played an essential role in monitoring 3I Atlas. Using publicly available telescope networks and open data, they have managed to capture imagery, calculate orbital updates, and track changes in brightness. This decentralized approach reflects a broader trend in modern astronomy, where professional and citizen scientists collaborate in near real time. Through forums, social media, and data sharing platforms, observations are cross-verified and refined. This cooperative model has allowed information about 3I Atlas to circulate even as institutional channels remain quiet. As the object continues inward toward its perihelion later in October, scientists are closely modeling its potential evolution. If 3I Atlas behaves like a typical comet, solar heating could cause increased outgassing, possibly expanding its coma further or creating temporary jets of material. However, given its anomalous behavior so far, predictions remain uncertain. Its structural integrity and unusual emission pattern suggest it may respond differently to solar radiation than any comet previously observed. Some models propose that its high speed and composition could prevent significant disintegration, allowing it to survive perihelion intact before continuing on a hyperbolic trajectory out of the solar system. Its approach to Mars provides another unique opportunity. While it is not expected to have any physical impact or visible interaction with the planet, the possibility of subtle magnetic or atmospheric effects is of interest. Mars's thin atmosphere and weak magnetic field could register disturbances from the passage of a large ionized object in its proximity. Instruments on orbiters and rovers may detect transient changes in charged particle densities or solar wind interactions, offering indirect measurements of 3I Atlas's plasma environment.
From a scientific standpoint, interstellar objects like 3I Atlas are valuable because they carry material formed around other stars. Each one that enters our solar system represents a sample of distant planetary systems, offering clues about their chemistry and history. The two previous known examples, Oumuamua in 2017 and 2I Borisov in 2019, demonstrated that such visitors are more common than once believed. Oumuamua, with its elongated shape and unexplained acceleration, inspired hypotheses ranging from natural fragmentation to alien engineering. Borisov resembled a conventional comet but displayed different compositional ratios, confirming that material from other star systems can enter ours. 3I Atlas, larger and more complex than either, could provide an even clearer understanding of interstellar matter. The observations being conducted now are expected to yield data on the object's composition, rotation, albedo, and possible outgassing patterns. Spectroscopic analysis from Mars orbiters may reveal the presence of carbon compounds, ices, and metallic elements. If 3I Atlas exhibits emission lines inconsistent with known cometary materials, that would indicate unfamiliar chemistry or surface processes. The collected data, once combined across missions, could establish whether interstellar objects form under similar conditions to those in our own solar system or reflect entirely different environmental histories. For the general public, the idea of an object from another star passing near our planetary neighbor is inherently compelling. It reminds humanity of its small but expanding awareness in a galaxy filled with motion and change. The fact that such a significant event can unfold while official channels are silenced by bureaucratic dysfunction emphasizes the disconnect between cosmic and political timescales. The universe continues regardless of institutional schedules, and discoveries depend on maintaining consistent access to the sky. As of now, the last available Earth-based image of 3I Atlas, taken on October 2nd, still shows its distinctive diffuse coma and layered internal structure. Its outer shell appears faint and extended, while its inner region remains brighter and denser, possibly corresponding to a nucleus several kilometers wide. The coma's gradient coloration may be the result of varying ionization levels within its gaseous envelope. Continued heating from the sun is expected to enhance its activity, though not necessarily in the same way as other comets. When 3I Atlas reaches its perihelion, it will likely be traveling at its maximum speed of about 68 kilometers per second. After that, it will begin its outward journey, eventually crossing Jupiter's orbit. The European Space Agency's JUICE mission will attempt to record its behavior from that vantage point. However, due to communication constraints, those observations will not be accessible to researchers until early 2026. At that point, the object will be moving away from the sun and gradually fading from view. Within a few months, it will disappear beyond the reach of even the most powerful telescopes, returning to interstellar space, possibly never to be seen again.
Despite the communication challenges caused by the NASA shutdown,
Scientists remain committed to tracking and analyzing every available piece of data. Independent astronomers continue to submit observations to open databases, ensuring that the event is documented for future study. The eventual compilation of datasets from Mars, Earth, and interplanetary missions will allow researchers to perform comparative analysis across instruments and wavelengths, producing the most detailed portrait yet of an interstellar object within our solar system. The temporary silence from NASA underscores an important lesson about the interdependence of modern science. While space agencies operate autonomously, their discoveries are interconnected. Interruptions to one nation's communication channels can delay global understanding of cosmic phenomena. At the same time, the participation of other space programs demonstrates the strength of international collaboration in maintaining continuity of discovery. 3I Atlas, whether it proves to be an unusually stable comet or an entirely new category of interstellar body, has already advanced scientific understanding simply by existing within view of our instruments. Each observation contributes to refining models of how material travels between star systems, how it survives long exposure to cosmic radiation, and how it interacts with solar environments when passing through another system. As technology improves and surveys expand, more such objects are expected to be detected. Each will provide another data point in the study of galactic chemistry and the dynamics of planetary formation. For now, 3I Atlas continues on its course, an emissary from elsewhere traveling through the domain of Mars, while human observers work through administrative and technical obstacles to record its passage. The timing is inconvenient, but also symbolic. The universe proceeds independently of human schedules, and scientific inquiry must adapt accordingly. Even amid shutdowns and communication blackouts, the flow of data continues through those determined to observe, analyze, and share. The story of 3I Atlas represents more than a single astronomical event. It is an illustration of persistence in the face of uncertainty, of decentralized observation compensating for institutional delay, and of a collective desire to understand phenomena that transcend human boundaries. Whether 3I Atlas ultimately resembles a comet, an asteroid, or something yet unclassified, its presence near Mars provides an invaluable opportunity to study an object forged around another star. The coming months will reveal more through the combined efforts of scientists worldwide. But even now, it stands as a reminder that the universe's motion continues, regardless of political pause or planetary concern. As this interstellar object moves past Mars and toward the outer reaches of the solar system, it leaves behind both data and perspective, a record of cosmic motion that endures long after temporary silence on Earth fades.